let's get into it. Today, we're going to build your very own Python toolkit. I want you to think about Python not as some complicated, rigid set of rules, but more like a super versatile collection of tools, the kind you can use to build, well, just about anything you can imagine. So, what are the really essential tools in this kit, right? We're going to break down the absolute fundamentals, the stuff you need to know to hit the ground running and actually feel confident when you're writing Python code. We're literally going to assemble this toolkit together, piece by piece. And I promise, by the end of this, you'll have a rock-solid grasp of the core concepts that pro developers use every single day. You ready? Let's dive in. Okay, first things first. Every good workshop needs raw materials, right? You can't build anything without them. Well, in Python, our basic materials are things called variables and data types. They're how we store and, categorize all the information that flows through our programs. So let's start with variables. Honestly, the best way to think of them is just as labeled containers, little boxes. You pop some information inside, slap a name on it, and now you can find it later. Super simple. But here's what's so cool about Python. You don't even have to tell it what kind of stuff you're putting in the box. It just figures it out. This is called dynamic typing, and trust me, it makes writing code way, way faster. And check this out. These are the different kinds of materials our little variable boxes can hold. You've got your simple stuff like integers, whole numbers, or text, which we call strings. Then you have booleans, which are just a simple true or false, but it gets cooler. We also have these more complex collections, like a list of items or even a dictionary that holds key value pairs. Seriously, these are the fundamental building blocks for everything you're going to create. All right, so we've got our materials sorted. But materials just sit there, right? Now we need the tools that actually do things, tools that tell our program what to do and when to do it. This is all about adding logic and repetition, basically controlling the flow of our code. And here's our first big decision-making tool. You'll see these everywhere: if, elif, which is just a short way of saying else if, and else. I love this analogy. Think of them like a GPS for your code. You give it a question, a condition, and depending on the answer, yes or no, true or false, the program takes a different turn. This is how you start making your code intelligent and responsive. Now, what about doing things over and over again? Python gives us two main tools for that. First, you've got the for loop. This is your go-to when you know exactly how many times you need to repeat something. It's like going through a checklist. You do it for every single item on the list, and then you're done. On the other hand, you have the while loop. This is for when you need to keep doing something as long as a condition is true. Think about waiting for a file to download. You don't know how long it will take. You just know you have to keep waiting while it's not finished. Okay, we're moving up to the next level of craftsmanship now, because writing the same lines of code over and over is, well, it's inefficient. Instead, we can create reusable blueprints. This is where we get really organized and efficient, and we do it using functions and modules. Functions are, no joke, one of the most powerful tools in your entire kit. The idea is simple. You take a chunk of code that does one specific thing, you wrap it up, and you give it a name using that def keyword. And just like that, you've built your own custom tool. Now you can use it anytime, anywhere, just by calling its name. This is absolutely the key to writing clean, professional code. But what if you need a tool that somebody else has already built and perfected? I mean, why reinvent the wheel, right? That's exactly where modules come in. Think of them as pre-packaged toolkits from the amazing Python community. You just import a module, maybe something like the math module, and bam! Instantly you have access to a whole library of powerful pre-built functions. You can calculate a square root without having to write a single line of the logic yourself. So our programs are getting pretty smart, but right now, they're kind of living in their own little bubble. This next set of tools is all about letting our code interact with the real world. We're talking about reading from files, and maybe just as important, learning how to handle things when they, inevitably, go wrong. You're going to be working with files a lot. It's just a super common task, and Python makes it incredibly simple and safe. The absolute best way to do it is with something called a with statement. The magic here is that you never have to remember to close the file when you're done. Python just handles it for you, automatically. This one little trick prevents so many common bugs. It's a lifesaver. But let's be real for a second. Code breaks. It just does. Even the best code can run into problems. Maybe you try to divide by 0. Oops. Or you look for a file that doesn't exist. Or you get some weird data you weren't expecting. When that happens, your whole program can just crash. So the big question is, how do we prepare for the unexpected? Well, Python gives us this really elegant solution. It's like a safety net for your code. You take the part of your code that might be a little risky and you wrap it in a try block. Now, if an error happens, the program doesn't just give up and crash. No way. Instead, it jumps over to the accept block, where you get to decide what happens next. You can handle the problem gracefully. This is how you build robust, professional applications that don't just fall over at the first sign of trouble. Okay, we have our materials, we have our tools, we know how to handle problems. The last piece of the puzzle is setting up our workshop like a pro. This means creating a clean, organized space for every single project, and knowing how to bring in all those amazing tools from the wider world. Listen up, because this is a non-negotiable. This is a best practice for any serious developer. It's called a virtual environment, and it's like giving each of your projects its very own, perfectly clean, totally isolated workbench. This way, the tools and the libraries you use for Project A will never, ever mess with the tools you use for Project B. It keeps everything tidy and prevents, oh my gosh, so many headaches down the road. And I know virtual environment sounds kind of complex, but look, it's really just a simple 4-step dance. You create it, you activate it, which is like stepping into that clean workspace, you install whatever you need for that specific project, and when you're done for the day, you deactivate it. That's it. Simple, clean, professional. So how do we actually get all those amazing pre-built tools we were talking about? The answer is PIP. It stands for Python Package Installer. The best way to think about PIP is like a giant, magical online catalog. You can find and install pretty much any tool you can dream of, all built by other developers from around the world. It's your personal gateway to the entire massive Python ecosystem. And that's it. There you have it. We've just assembled a complete professional-grade Python toolkit from the ground up. You now get how to store data, how to control the logic of your code, how to build your own reusable tools, how to deal with files and errors gracefully, and how to manage your projects like a total pro. So, the workshop is all set up, your toolbox is full, the materials are all there waiting for you. There's only one question left, and it's the most exciting one. You have the tools, so what are you going to build first?